Hello everyone. Welcome to our week 4 question reviews. Let's first see our first question. Okay, so the question is asking how many eggs are needed to make 3 dozen waffle, assuming you have enough of all other ingredients. So let's write down the recipe or the equation first. Basically, it's 2 flour react with 3 eggs plus 1 oil will give us 4 waffle. Okay, so the relationship between the eggs and waffle are like 3 eggs will give us 4 waffle, right? So the question is asking to make 3 dozen of waffle. 3 dozen, we know 1 dozen is 12, so 3 dozen are 36. So from the reaction itself, we know 3 eggs will make 4 waffle. Then how many eggs do we need to make 36 waffle? So we can calculate the question mark as 3 multiplied by 36 divided by 4. The result will be 27. Okay. Next question. This question is asking which ingredient is a limiting reactant if you have 6 cups of flour, 9 eggs, and 2 teaspoons of oil. So a common mistake that people usually make is they just assume the one with the reactant with the least amount is a limiting reactant. So I can tell you that is absolutely wrong because in that case, we didn't consider the contribution from the coefficient of each component. Okay, so how do we do that? If you really want to compare, here is a trick. Okay, here is a trick. Do not directly compare the amount, the provided amount. You should try to normalize the amount. Okay. So what I mean by normalize here is you need to use amount, provided amount divided by the coefficient of each component. Okay, that will give you the normalized amount. It means after this division, operation, we have normalized or we have get rid of the impact from the coefficient. So by that, we can directly compare. Now let's see how do we apply. So for this case, we know there are 6 cup of flour and the coefficient for the flour is 2. So after normalize, we got 6 divided by 2, we got 3. Okay. The egg, we have 9 eggs, and after normalize, we divide it by 3, we also get 3. But for oil, we have 2 teaspoon oil. After normalize, because the coefficient of oil is 1, after we normalize, we got 2. It means after normalize, the oil, it is the smallest. It is the least amount, which means the oil will be the limiting reactant. Okay, now let's see the next question. So how many grams of water are theoretically produced for following reaction given we have 2.6 moles of the HCl and 1.4 moles of the calcium hydroxide? Okay, let's try to write down the reaction. 2 HCl react with 1 calcium hydroxide will give us 2 water and calcium chloride. So to solve this question, the step 1 is still we need to figure out which one is a limiting reactant. Okay, so which one, HCl or calcium hydroxide? So if you see the statement of this question, 2.6 moles of the HCl is provided and 1.4 moles of the calcium hydroxide is provided. So which one is the limiting? Still, we should not directly compare this value. We need to normalize, okay? So if we normalize the HCl, which means we divided by the coefficient of 2, we got 1.3. And if we normalize calcium hydroxide, we got the number of 1.4. So because 1.3 is smaller than 1.4, so the 1.3 is a limiting reactant, which means HCl is a limiting reactant. Okay, so once we got the reactant, we need to use use the coefficient of the uh, of the reactant and find out the amount for the product. Okay, so it's asking us water. So how do we find out the amount of the product? The amount of the product can be calculated as using the normalized amount of the limiting reactant. Okay, of the limiting reactant times the coefficient of the product. Okay, so what is a normalized amount of the limiting reactant? So normalized amount of the limiting reactant is something we just calculated, right? It's 1.3 because 1.3 is a smaller value. And the coefficient of the product, we have two products now, the water and the calcium chloride. So which product should we use? Let's go back to the question. What is asking? It is asking us how many grams of water, right? So it is asking us the water as a product. So that's why the coefficient of water is 2. So we multiply by 2. That will give us 2.6 mole. Okay, so now we have successfully calculated the amount of the water. But the question is asking us the gram, not the mole. So how do we convert the mole into gram? We convert the mole into gram by multiply the molecular mass, right? So for the water, it's H2O. We need to find out the molecular mass of the water. So we go back to our periodic table and find out the atomic mass for helium, which is 1.1, and the atomic mass for the oxygen, which is 16. So we can calculate the molecular mass for water is 1.01 times 2 plus 16, which will roughly give us 18 or 18.02. So now, in order to convert the mole to gram, we want to multiply uh, 2.6 with 18.02. That will give us a result of 46.8 grams. So in total, 46.8 grams of the water will be generated. Okay, next question. This question is asking, consider the following reaction. 2 magnesium react with oxygen will generate the 2 magnesium oxide. For this reaction, the enthalpy is negative 1111 kilojoule. Okay, so calculate the amount of the heat associated with completing the reaction of 4 moles of the magnesium. As we discussed on our class, so for the stoichiometry can not only apply to the amount of the reactant or the amount of the product. Stoichiometry can also apply to calculate the amount of the energy. Okay, so from this reaction, we know like 2 magnesium after the reaction will generate enthalpy of 1111 kilojoule. Okay, negative 1111 kilojoule. So how much energy will be generated if we are not using 2, we are using 4? So this will be our question mark. So our question mark will be 4 multiplied by 1111 divided by 2, which will give us 2222 kilojoule of energy. So that will be our answer. Okay, so let me recap it again. So for the stoichiometry not only can be applied to the amount of the reactant, amount of the product, stoichiometry can also be applied to calculate the amount of the energy that absorbed or released from a given chemical reaction. Okay, all right, let's see the next question. Next question is asking us which of the atom represented below is the largest in size? Lithium, sodium, potassium, or this rubidium. So how do we do that? So uh, from what we learn, we know for the same column, the radius or the size of the atoms are monotonically increasing. So if we go to our 1A, or we can go back, we can go to our periodic table. If we go to our 1A, it means from the top to bottom, the size are gradually increasing because they have more electrons surrounding them, surrounding the nucleus. Okay, that is why the size of the lithium will be smaller than the size of the sodium, and the size of the sodium will be smaller than the size of the potassium, and the size of the potassium will be smaller than the size of the rubidium. Rubidium. So, in this question, which the atom represented is the largest one? It is apparently the rubidium. Okay. Next question. Based on the relative location on the periodic table, a carbon atom is larger in the atomic size than a germanium atom. So we try to locate where the carbon atom is. Here's a carbon atom. And where's the germanium atom? Here's the germanium atom. As we just discussed, for the same column, the element from top to the bottom, the size of the element are gradually increasing. Okay, so which means the size of the carbon will definitely be smaller than the size of the germanium. Okay, so the typical trend is for the same column, the sides from top to bottom, the sides are increasing. But for the same row, for example, for the same row, the sides from left to right are gradually decreasing. Okay, let me repeat it again. For the same row, the sides from the left to right, the size of the atoms are gradually decreasing, which means the boron will be larger than the carbon, carbon will be larger than the nitrogen, nitrogen will be larger than the oxygen, and oxygen will be larger than the fluorine. Okay, next question, true or false? The energy of the light is proportional to the light wavelength. This is false because the light of the energy is inversely proportional to the light wavelength. The longer the wavelength is, the lower the energy is. Okay, so last question. The red light is more energetic than the blue light. This is also a false statement because the red light have the longer wavelengths and the blue light have the shorter wavelengths. Longer wavelengths means it is less energy or less energetic. So the red light is have the lower energy. Okay. Okay. So this is a brief question review for this week 4, and I hope it is helpful to for you to get prepared. And thanks for your attention. Bye bye.